In this video we're going to look at deriving the area of a circle using calculus and integration. So we know that the area of a circle is pi r squared, but let's derive this formula using calculus. So if we take an angle theta and we increase that by a very small angle delta theta, we have a little segment of the circle here. The arc length there by geometry is r delta theta, and we can extract this little triangle and approximate it as a right angle triangle because of the very small angle there. So we have delta theta as the angle, we have a radius, we have the height of the triangle being r delta theta, and we can calculate the area of this triangle. So the area of a triangle is half base times height, so it's half times the radius times r delta theta. So that'll be half r squared delta theta. We can now use this calculus to integrate this formula 360 degrees around the circle, or 0 to 2 pi radians. So the area of the circle is the integral from 0 to 2 pi of this formula, half r squared d theta. Because we're using calculus, we change that to a d theta now. So we can take the constant at the front of the integral, so we can now clean this formula up. The 2's cancel out and we can see we have pi r squared, which is the area of the circle. There is another way to use calculus to find this area formula, and this time we're going to use rings. So we have a circle and we draw a single ring. Within that circle we can calculate the area of this ring and use this area then within calculus to derive the area of the total circle area formula. Well, the circumference of the inner circle there is 2 pi x, and the circumference of the outer circle there is 2 pi x as well. We could calculate the circumference of each of those rings. We know the distance between those is delta x, a very small distance. So the area of this ring is 2 pi x multiplied by dx, if the distance between those two rings is very small. So if we roll that out into a rectangle, that ring, we get delta x being the width and 2 pi x being the distance. So using calculus, the area of the full circle with a radius of r, we can calculate rings all the way to the outside of the circle. So 2 pi x times delta x. Delta x becomes dx with calculus. You can take the constant outside the integral and integrate x, which becomes x squared on 2. Then evaluate this at the limits.